And then, are there any other roles for telomerase
That's an extremely
extending the
controversial
telomeres?
question right now. Yeah, there are quite a number of studies out there now indicating that there might be what are being called extra telomeric roles for the enzyme telomerase. But the evidence is still pretty shaky, to be honest. A lot of the relevant experiments haven't really been done. In some cases, it looks as though the um, function of the gene of the enzyme telomerase is actually dependent only on one of the two major subunits of telomerase. Telomerase has a catalytic component, which is a protein, and a template component, which is an RNA. And it's actually the catalytic component which is normally turned off and not expressed in most of our cells. Um, it appears that the extra telomeric roles may sometimes be performed only by the catalytic component, independent of the template component. And of course, that allows the possibility that we could implement wilt only by knocking out the gene for the template component. Another thing we need to bear in mind is that the experiments that have been done looking at the possibility of an extra telomeric role for telomerase have typically been done in mice. And mice express a lot of telomerase in a lot of different cells, including in cells that don't tend to divide very much. So there may very well be a different role, an additional role, but in human cells, every cell type expresses either no telomerase at all or as little as it can possibly get away with. And that indicates to me that insofar as there are roles for telomerase away from the telomere, those roles have been substituted by other machinery in humans. So I'm not too worried about that possibility.
Can we knock out telomerase right now from human cells?
We can certainly knock it out from human cells. What we'd like to do is knock it out from human organisms that are already alive. And of course that would involve a very sophisticated amount of gene therapy. In many cases we would be able to do it in for example, stem cell compartments by doing the manipulation ex vivo in the laboratory, and then eliminating the endogenous stem cells and replacing them by, for example, a bone marrow transplant in the case of the blood. But those techniques are also pretty difficult. And in the case of cell types which are not regularly replaced by stem cells, but which are mitotically competent and therefore necessary to be manipulated in this way in order for wilt to work, in that case I feel that we would have to do bona fide somatic gene therapy. So we've got a lot of work to do to make gene therapy work much more safely and much more effectively.
How do you think we bring about more collaboration between researchers?
More money, to be honest. Collaboration is generally well regarded. Researchers like to collaborate, and actually funding agencies like researchers to collaborate. So you would think that collaboration would be the rule, would happen more often than not. But actually, no, we don't see that. We see less and less collaboration. And the fundamental reason is that people like to, well, people need to get their grant applications funded, and they perceive, in general, scientists perceive that the best way to get funded is to apply for money to do stuff that they are already known to be good at. In other words, to stick to what is already their speciality. And of course that inevitably results in more and more balkanization, less and less collaboration, less and less diversification. I think that what this means is that people like myself who are not working in the laboratory but who are monitoring the literature and coming up with new ways to combine work that happens in different areas, people like myself are becoming more and more necessary, and there are not nearly enough of us. I actually, one of the reasons why I moved into biology originally 15 years ago from my previous career in computer science was because I saw that in contrast to physics, for example, where there are whole departments of theoretical physicists, in biology, unless you're doing experiments, or at least writing the grants to do experiments, you're generally not considered, very respectable. And there's virtually no senior, well-respected biologists who work in that way, despite the fact that the few that there are tend to have quite a good hit rate in terms of making contributions. So the answer is more money will cause more collaboration.
Perfect. And then would you agree that pharmaceutical companies aren't on the right path right now when it comes to cancer?
Well, pharmaceutical companies are always looking for magic bullets because they are companies and therefore they are driven by short-term financial gain. I don't think we can usually look to pharmaceutical companies to be the real pioneers of real cutting-edge long-term therapies and research, whether it's in cancer or in any other area of medicine. So I think in their own terms, cancer is probably being treated reasonably appropriately by the pharmaceutical industry. But what we need is for the academic world to be driving forward on things that are too far off to be commercially interesting.
Perfect. And then what would you say to people who need treatment now? Because most of these ideas tend
Well,
to come about 10 to 15 years.
because the absence of treatment now is not something that only applies to cancer. No, I mean, the whole of aging is something that we can't treat yet. Generally, what I say when people ask me what they can do today, I say, look after yourself the way your mother told you to and don't smoke and so on. And also, do whatever you can to hasten the development of therapies that don't yet exist by making sure that the appropriate research is suitably funded. So if you're a billionaire, give money to the appropriate charities. If you're a journalist, get me on the television or on the web or whatever. And so on. And of course, if you're a biologist, work in the right area. So that's really the answer for cancer as well. There is no magic bullet for cancer. Of course, some cancers that's not true. Some cancers we have made very good progress. And I already mentioned immunotherapy for cancer, a very promising area. There's not enough work going on in it. There are some tantalizing results out there that are not being pursued nearly as aggressively as they could be. So we do need people to get involved in, experimental work in phase 1 trials, for example, especially when they have advanced cancer, to see whether we can actually get these immunotherapies for cancer to work better than they currently do.
What would you tell people who are doing experiments looking at the whole genome right now?
I mean, chromosome instability is unquestionably a very large part of the etiology of cancer. And I think that we are progressively understanding the way that cancer develops better and better by taking into account the mechanisms of mutagenesis, such as chromosome rearrangements and epigenetic changes and so on, that have been quite difficult to quantify and evaluate until recently. Where I'm not so enthusiastic is the whole genome analysis of which mutations actually seem to matter in cancer, which specific mutations. I think the message that we are receiving from work that tries to identify which genes tend to be mutant in different cancers is, not very surprising and not very useful. Essentially, we're finding out that, lo and behold, cancers find a very wide number of ways to elude and evade the immune system and indeed all of the therapies that we might throw at them. And therefore, all we're coming up with there is reasons to be pessimistic about the development of therapies, as opposed to coming up with information that we can use to develop therapies. That's another reason why immunotherapy against cancer is quite promising. The basic idea, at least for many of the approaches to immunotherapy against cancer, is that you don't have to identify what antigen you're going after. And of course that's also true in the case of wilt. It doesn't really matter how the telomerase enzyme got turned on. If it's turned on, you want to get rid of it, right? So if you get rid of it before it's been turned on, even better, which is what wilt is trying to do.